Hello everyone, welcome to Analytics with Asmi.
In this video, we are going to see what is chi-square test and how we can find if the two variables are related to each other or not by using this test. So let's start. A chi-square test is used in statistics to test the independence of two events. Means it is used to see if there is a relationship between two categorical variables. Categorical means which represents the characteristics like gender, marital status, education level, eye color, etc. Suppose you have two categories like favorite color and gender, and you want to know if there is any connection between them, then you can use this chi-square test. This test helps you to find whether any correlation between these two variables or not. Here we have to compare the observed frequency of each combination to the expected value. Let's say you have a group of people and you record their favorite color and gender, and you would tally how many men or women like each color. Then using this chi-square test, you can determine if there is a significant association between gender and a favorite color. In simple terms, the test tells you if there are any pattern in the data or just a random chance. If test shows a significant result, it means that there is a likely some relationship between these two variables. If not, they are probably independent of each other. Now we will see practically how chi-square test is used to find out whether the two variables are related or not. First of all, we need to find out what is our aim and why we are using a test. Suppose we have taken this scenario. Look at this table. In this table we have two categories. One is education qualification and second is marital status of a person. Now what our aim here is to calculate or state whether these two variables, which is qualification and marital status, are related to each other or not. So we will start defining our null hypothesis and alternate hypothesis. These are fundamental concepts in statistics, hypothesis testing. So what is null hypothesis? It is a statement that there is a no significant difference, effect or relationship between the variables being studied. It just states that it's just a random chance. And alternate hypothesis is opposite to the null hypothesis. It's a statement that there is a significant difference, effect or a relationship between the variables being studied. This is what researchers typically want to prove or support. So here in our scenario, our null hypothesis will be there is a no relation between the marital status and the educational qualification, and our alternate hypothesis will be there is a significant relation between the marital status and the educational qualification. Now let's see by calculating all these. Before that, let's define the significance level. Significant level can be either be taken as 0.05, which is a 5% from the deviation from mean, or we can take it as 0.01. Usually significant level taken as a 0.05. There are different significant level taken for different observations, but generally it is taken as 5%. So we will go with this value only. Now you can see the spreadsheet here in which there is one table. Okay, now how to start here? First of all, we will look at the observation values. Values which are observed are given in this table. So in this table you can see these are all values, and here these are row total, and here you can see the column total, and 300 is a total grand total, means 300 are total values here. Okay, now we are going to prepare another table here with the same variables, but those value will be the calculated values or expected values. These are observed values. Now we have to do a calculated values, so we have to do some calculation. So now how to calculate it? In this table you can see that there are 36 people who are unmarried and having a high school education. For those people, we can calculate the expected value as row total into a column total divided by this grand total. Okay. So here you can see that we have calculated the expected value by multiplying row total into column total divided by grand total. So row total for that particular person was given as 90, column total was 90 and divided by 300, and we got this expected value. So you can see that I have created this another table, which is a table of expected value, by doing the same calculation. So here you can see for the first value, which is for this person, which is 18. So we have calculated the value, expected value, as 90 into 39 divided by 300. Why it is so? Because the row total is 90, then column total is 39 and divided by 300. Similarly, we are doing same for this 12 number. So for the 12 number, the row total is 150 and column total is 39 divided by 300. Similarly, we have calculated for all this value and we are getting this expected value for all the persons. Okay. Now you have seen that we got two tables, one for observed value, one for expected value. Now here our aim is to find out how much deviation is there between observed and expected values. This can be found out by using a simple formula, that is observed value minus expected value whole square divided by expected value. So now we have to again prepare a new table which tells the difference between these two values. So now look at this table. Here you can see we have these 5 columns where all the observed values are written in the one table, which is observed value. Expected values are written in another column. Then we have taken the difference between these two. Okay, here you can see the formula. We have taken B3 minus C3 and we got the difference. Then we have squared this difference. Okay, you can see that we have squared this. So we got O minus E whole square, and finally this is the chi-square formula, and in which we have put all the values and we are getting this final value, and we have calculated this chi-square value for all the persons. Okay, and here we are getting this summation of the formula, which is the calculated value of chi-square, which is coming as 23.57. So here this 23.57 is a calculated value of a chi-square. Now we need to compare this value to the tabular value of a chi-square. Now here you can see that this is a tabular value of a chi-square. So all the tabular value of chi-square is given here, and this is for 0.05 significance, because we are looking for this 0.05 significance, and here is the degree of freedom. So we have a calculated value of a chi-square. This is a tabular value of chi-square. So we have to compare with this, but for comparing we need a degree of freedom. So first we need to calculate the degree of freedom. So how to calculate the degree of freedom now? Degree of freedom can be found out by a simple way. We can use this formula where degree of freedom is equal to column minus 1 into row minus 1. So in our table there were 5 columns. So we have done 5 minus 1 into, and there were 4 rows. So 4 minus 1. So we finally got this 12 degree of freedom. Now we have a significance value which is 0.05 and we have a degree of freedom as well. Now we can calculate a tabulated value of a chi-square. Now here you can see the tabular value of 12 degree of freedom and 0.05 significance level. The value is getting as 21.026. So this will be the tabular value of chi-square. So finally we got all the values of chi-square test. So we got a calculated chi-square value as 23.57 and we got tabular chi-square value as 21.05. Now here we can see that calculated chi-square is greater than tabulated value. So when the calculated value is greater than the tabular chi-square value, then we can state that null hypothesis is rejected and alternate hypothesis is accepted. Now what was our alternate hypothesis? Alternate hypothesis was there is a significant relation between marital status and the educational qualification. So this is how we have calculated the chi-square test to state whether two variables are related or not. So here we can state that these two variables, which are the marital status and educational qualification, are related to each other. Hope you understood how to use the chi-square test. See you in the next video. Thank you for watching.